Yes.
Okay.
So we're Campus Compass, and we help Aggies find their way. My name is Ben Beadle. I'm a senior in computer science major graduating in May in London.
My name is Colby Cartwright. I'm a senior computer science major, and I graduate in December.
My name is Homer Wabisky, and I'm also a senior, and I'm graduating in May.
My name is Jennifer Tunn. I'm a super duper senior. I'm a math and computer science double major, and I'll be graduating in May.
So this is my BFF, Bobby Joe. Bobby Joe is done with classes for the day, and he just ate at Savisa Dining Hall, and he needs to go to the College Marine Apartments to study with a friend who lives there. He doesn't have a car, and he doesn't have a bike, so how is he supposed to get there? Really the only way is to use the bus system, right? But if he doesn't know, if he's never used the bus system or he's never used it to the College Marine Apartments, how is he going to know where to go?
All right, so this is Rick. He is a company representative who has never been to A&M before. He is trying to get to the Career Center. He has parked in the parking lot on campus, but he does not know how to get to the Career Center from there. How is he going to get there?
This is Meredith. It's the first day of classes, and she has one hectic schedule. She wants to get to class on time, but she has no idea how to do it. What should she do?
So given these problems, we wanted to find a solution, and we saw a need and wanted to fulfill that need. So with that, we're introducing Campus Compass, which helps new students, visitors, and other Aggies in the Bryan College Station area access to the TAMU bus system efficiently and easily. So no longer should users have to stare at the Transportation Services website in confusion scratching their head.
So, some prior work, everyone has heard of Google Maps. The problem with Google Maps is they don't provide a lot of on-campus data such as buildings and parking lots. So, therefore it falls short of on-campus navigation. Another service provided by Google is Google Transit. It integrates public transportation in metropolitan areas and major cities. However, it does not support Texas A&M's bus system and its continually changing schedule. And then this is the website that is provided to users, which gives them access to route times and bus routes. The problem is that it only gives major bus stops, and there's no intuitive way to get from point A to point B.
So we have several hypotheses for Campus Compass. It is a bus routing application for A&M and the BCS area. We hope that it will use the TAMU bus system as a primary mode of transportation in addition to walking, and that it'll be easy to use, so everyone's really happy. I guess we also have some ethical and professional concerns to address because we want to make this an app that everyone can use. One of those is privacy. If we kind of eventually want to track user data in order to improve accuracy of our app and help users get around more efficiently. That brings up the issue of privacy, which is an ever-growing concern. We also have a concern with situation blindness. Situation blindness occurs when one is so hyper-focused on one stimulus that they miss other stimuli going around them. With Campus Compass, if a user is so focused on figuring out the directions from one place to another, they don't realize other stimuli around them. That's actually a physical hazard that they have to worry about.
So I did the backend server, and I also wrote some APIs that the other three frameworks could use.
I did the web app.
I worked on the iOS development.
And I worked on the Android OS development.
So, in order to make Campus Compass, we need a large amount of help from some multidisciplinary people. And Chris and Jim, they gave us permission to use the Aggie bus data through the A&M API, which gave us points of interest and coordinates abilities that we can't really find on Google Maps. Wesley Shine was very influential in getting us to switch to Google App Engine. Before we were using Ruby on Rails, which was kind of futile for what we were trying to do with it. And Randy Davidson gave us some TAMU bus system data, which was, in the end, not very helpful, but set us on the right track.
So for the server, we use Google App Engine. Google App Engine, we wanted to make it really efficient and easy to use for both us to develop and for our users. And Google App Engine allows the app to be easily maintained and scale as our user base grows, and also provide a really big framework of different services that you can use to easily integrate into your app and provide features.
So one of our biggest design choices was to develop our application natively on 3 different platforms, the 3 platforms being web, iOS, and Android. The reason why we did this was because there would be a lot less bugs if we developed them natively, and it gives a seamless experience across all 3 platforms. So for example, if you have a user switching from an iOS phone to an Android phone, they'd still be able to use our app without running into obstacles.
So like I said, I used Google App Engine. Go ahead. So these are some of the services that I used for the backend. I used cron jobs, which allow for scheduled tasks to be completed. And so in the morning, we run a cron job every morning to process data early. And that way we don't have to run it like whenever the users are actually using the app. Because at like 5 a.m. the users aren't going to be using the app because there's no buses running at 5 a.m. So we also use task queues, which allow for processing in the background. So whenever a user has a request for a routing request, then we do task queues and we can do it in the background. And so that frees up space for the web app and for bandwidth as users are using our API or using our app. And then our endpoints API is a service provided by Google that allows me to write code and give different API commands and such that allows it to be easily used through the 3 different frameworks. And then Dexter's algorithm is the shortest path algorithm that we use for actually finding the routes. And so we have like a graph, and the nodes are the actual bus stops, and then the edges are the connections between those bus stops of like the different routes and stuff.
So the front end consisted of Jen, Omer, and I calling Ben's API in order to deliver the routes and points of interest to the user. And we were able to get the Aggie bus data working on the iOS and Android, but unfortunately not on the web app because of some red tape.
All right, so this is screenshots for the Android system. So the one on the left is the main screen. It has router, kind of our little mascot. And then the one on the right, has an example image of the start location with the map. And it's currently selected on our current location, which is Bright Building. All right. When you tap on that text box that's at the top, it'll bring up a little search menu, so you can use your current location to search Google Maps for like streets or intersections. And then the third one is bus stops and buildings, points of interest, and parking lots on campus.
All right, so this is some screenshots of iOS. It has the same basic structure as the Android application with a few minor details being changed because there are things that are easier to do in Android than iOS. So for example, the drop-down menu isn't there, but at the beginning they're asked if they want to use their current location as their start location. If not, they're able to use these 2 buttons down here to select whether or not they want to search on campus or off campus. And here's the end location. Right now it is they are searching for the Bright Building, and this is a screen where the directions would be displayed along with the route.
So we've done some user studies, and we are continuously doing user studies to figure out how we can better our app. We have both qualitative and quantitative questions. And qualitatively, we want to really just understand how users navigate campus and use the bus system so we can provide a better end solution for them that actually gets done what they want to get done and not just what we think they want to get done. And then quantitatively, we just want to get feedback on if they're actually going to use Campus Commerce, and as opposed to transport.tamu, and if not, then how can we better it so they're more likely to use it.
We have won a couple of awards. During Student Research Week, we tied for 2nd place in the undergraduate poster presentation for the Math, Computer Science, and Statistics category. And we also tied for 1st place in the Melbourne G. Glasscock Humanities Award, which emphasizes multidisciplinary work and work towards the humanities.
All right, so during SRW and the Texas A&M's Project Engineering Showcase, we were able to allow users to use our app, and they gave us some preliminary feedback. Some of the things they provided us with were strategies for getting more accurate walk and ride times. strategies for being able to take into account walking through grassy areas or buildings, and they expressed support in trying to get Campus Compass officially deployed for tasting.
So like I said, we're still doing test user studies and such. We do have some like short-term and long-term goals. Short-term,
Sorry.
short-term, we really just want to make an app that's useful and is real-world applicable. And we do want to compare it to transportation services and see how we can make it better and more useful to the users. And the long-term goals, we do want to integrate it with transportation services, like Homer just mentioned, and actually get some more accurate data than we're being provided right now, and improve the features that we currently have, and then add more features in the future.
So we had some pilot tests around campus, mainly in the CS building. So this means they're mostly CS majors, 5 students to be exact. It's a pretty even split between male and female. People would take a variety of paths. Initially, they chose the Find My Route option. They didn't use the view bus routes very much, mainly because it's the first option on the list, and they would also almost always choose the current GPS location as their starting point. I'll search for on-campus buildings, and they use it for about 2 to 3 minutes. And the feedback we got was our initial design was not intuitive enough. They would sometimes follow around because they're used to Google Maps. But they did agree that Campus Compass would be very useful and a real world application. So the conclusions that we got were.
All right, so really quickly, things that we would have done if we could go back in time and change things. Completed early user studies to find the best UI design to kind of combat what Kobe just mentioned about bad UI design. Also implementing more features. That was more or less a time management issue versus we're not doing enough features. And then improving documentation throughout the development process versus doing it at the end.
So some future work we'd like to do is give the ability to give the user bus capacity so that they know which buses are full and empty. Give them the possibility of walking in between buildings and grassy areas. Track their use of the app to better improve it, and give them alerts when buses are approaching or when they need to change buses or get off at a bus stop.
All right, let's do a little demo video. Be excited. Hopefully it loads enough. There we go.
Cool, how's it work?
Here, let me show you. Any questions?
So it looked like you did integrate the routes with the bus routes, I'm sorry, with the shortest path. Is that, you doing
Correct.
that? How did you link those two data points together?
So it's actually like a huge graph, and each node, like I said earlier, is the stops. And so I actually have a stop for each route. So like if a stop is used multiple routes, then I have a different node for each route. And so I just create edges, and the edges are like the duration of how long it would take to get from that node to another node. And I just run Dijkstra's from this node to this node.
So if you're up on the nodes, we get a smaller time frame, so then the shortest route will take.
Right.
Okay, cool. And then question on you mentioned the path stuff. So I guess I imagine on campus are not all the buildings or routes populated. Can you supplement that, or did you have any issues with that?
So we're using the 3 different APIs. We're using Google Maps, which is for off-campus like apartments and stuff like that. And then we're using the ID Map API, which is for the points of interest in buildings. And then we're using an API that I wrote, which you can do search bus stops. So you can pretty much go from anywhere to anywhere that you want to.
In the BCS area.
Yeah.
So do you have walking routing as well, or just bus?
It's walking as well.
Okay.
So sometimes walking is faster than just riding the bus.
So you said you developed natively on your mobile apps.
Yes.
Did you try doing like a design once web app, or have you done any investigation of why you didn't go that route? I'm just curious more than anything.
So the primary reason why we didn't want to use wrappers is Facebook. So they used for a while a wrapper for their mobile app, and it was horrendous, for lack of a better term. And so we really didn't want to have all these bugs and stuff, like kind of the same issues that.
You're afraid the different screen sizes would be a problem, or was it performance?
A little bit of both.
Okay.
And we did want to make the apps more intuitive per users, because Android users are not always iOS users, are not always web users. So.
So you can make use of the different buttons and stuff
Exactly,
like that.
yes.
And I remember when Facebook updated their app from the wrapper to the native, and it was just so much faster and it was just easier to use.
I have to say that Google's web maps is more difficult on phone than the
What was the toughest computer-related problem that you saw?
So for me, I didn't actually start using Google App Engine until mid-March, spring break. I never touched it before. And so from then until now, I've learned a lot, and I've had to learn a lot about Google App Engine and their services and stuff. So it's a huge learning curve.
On client side, actually using Endpoints API was really difficult because he coded everything in Python and Android develops in Java. So the libraries that were generated for the Android version didn't have class libraries that went with it. So we had to do a little workaround to kind of get that working, but we did it at the end.
The point was to make it really easy for that, but since I was in Python, when I followed the steps to translate it over to Java for the API, it just wasn't working at all.
Okay.
Yeah, and the biggest problem with iOS was getting the developer's license to test it on an actual iOS device. I thought it would be simple, just like Android, just plug it in and deploy it, but apparently not. So we keep working on that. So.
Any other questions?
I'd like to hear. Go ahead.
Well, on the web app end, I didn't run into too many problems. We started out Ruby on Rails, so I guess it was a pretty big transition to go from that platform to GAE. But I'm very glad we did. It was a lot easier to use. Also, just I guess getting Google Maps to work with Ben's API, like feeding the data I get from him to Google's API was kind of difficult for a while.
I have a question.
Sure.
So I heard you guys say that in terms of the privacy and the concerns around the
Situation blindness.
professional and ethical responsibility. You mentioned that you guys had knowledge that there was situation blindness and the user information being perhaps exposed. I didn't hear you guys say how you were planning on or how you address that.
So right now, privacy is not a very big issue. I think right now we're not collecting any data per se,
Okay.
nor are we saving data. In the future, though, if we want to make our app more robust, more accurate, even like including capacity, bus capacity, we would collect data, and that's when privacy would become an issue. And I guess at that point, we would start addressing it. And
Okay.
So is that what you were planning on doing, is crowdsourcing data for the bus pass?
we would like to.
Okay.
We would like to.
Thank you.
How'd you break up your work? Who
It's
decided
like-
to do what?
It's actually kind of funny because we kind of outlined, so backend, iOS, Android, web, into these categories. And we kind of use a little Likert scale to decide, like, who would you prefer to do this or not? And so we all did little rankings, and whoever got the highest ranking for whatever, yeah, that's what they got. So,
They kind of like just naturally fit into the
Yeah.
roles.
Did you feel like anyone got the short end of the stick? Like someone had tons of problems with, like maybe your iOS and the Android was a lot easier in terms of just raw time put into it.
I don't feel like I got the short end of the stick, but iOS was definitely took some getting used to. I eventually got it done, but it was kind of difficult at the beginning.
and I didn't have as big of a learning curve because I had previous experience with Android development, so I guess I had a little head start there.
What was the team structure?
So Kobe was our leader. He kind of kept us in line, and I was kind of like the.
Assistant team.
I kind of made sure things got done on time, or at least close to on time. Plus or minus 10 minutes a day.
Did you have like a plan at the beginning saying, okay, we want this done by here, this done by here?
Yeah, we did. We developed a Gantt chart as well, and we did have a lot of tasks outlined, and we had a lot of features that we wanted to implement, but we didn't plan out how long those tasks would take. Also, things like getting the iOS development license. We thought we'd get that in a week. It's apparently taking a semester.
And just, sorry.
yeah, go ahead. It's like other kind of logistics like that kind of like push things off, but otherwise we accomplished our baseline.
And just switching from Ruby on Rails to Google App Engine, I kind of had to like stop all the tasks that I had assigned just to learn Google App Engine.
Thank you so much.
Thank you very much.